All right, hello everyone. It's Kalen Langley again in ECE 275 Digital Design. This is lab number 6, and the objective was to design an 8x3 encoder using two 4x2 encoders and any other additional logic necessary. The first task was to design the paper circuit, and I'll go ahead and pull that up now. Recall that encoders have two conditions, and they have 2 to the power of n inputs and n outputs. And the second condition is only 1 over 2 to the power of n inputs can be a 1. And that the equation for A is either input 2 or input 3, as you can see with this little diagram of a 4x2 encoder. And then B is input 1 or input 3. So if we step that out here, whenever I0 is a 1, A and B are 0 and 0. Whenever I1 is a 1, you'll have B, so you have 0, 1. Whenever I2 is a 1, you'll have A, so 1, 0. And whenever I3 is a 1, you'll have A and B, so 1, 1. We took that logic and then we made two 4x2 encoders. So inputs 0, 1, 2, 3, 4, 5, 6, and 7 here for encoder 1 and encoder 2. And we added some additional OR gates to convert these two to a 8x3 encoder. So we'll step it out through the truth table using these equations / kind of the logic gates just to check it out to make sure it matches up. So whenever I0 is a 1, everything will be off. And you can see that here. So these both will be off for encoder 1 and encoder 2. They're both off, so A, B, and C are 0. Whenever I1 is a 1, B will fire and C will turn on. So you have 0, 0, 1. Whenever I2 is on, A turns on, so you'll have B. So that's 0, 1, 0. I3 is on, both turn on. So you'll have B as well as C. So 0, 1, 1, 0, 1, 1. All right, now going to I4, in order to make the 8x3 encoder, we drew a line from I4 to output directly to A. So you'll have A 0, 0 or 1, 0, 0. Now to I5, B2 turns on. So we have B2. So C is on. But there's a junction here. So also we have A on as well. So that's 1, 0, 1. Going to I6, whenever I6 turns on, A2 is on. So you have A as well as B. So 1, 1, 0. And then whenever I7 is on, all of them are on. All right, so A and B are both on. So you have B, you have A, and you have C. 1, 1, 1. All right, and the next assignment was to build the design logic in Quartus, and then use structural programming and call the encoders. So I built the 4x2 logic here, and we're using V to determine whether it's a valid input or not. And then we take that, the 4x2 encoder, and we call it in this programming here to make the 8x3 encoder. Now, the next step of the assignment was to conduct a model sim simulation with a test bench to test all active inputs. So we have input 0 through input 7, and then we have A, B, and C for 2, 1, and 0. So whenever I0 is on, Everything is off. We'll go to I1. This guy is 0, which would be C, will turn on. And that matches our truth table. Okay, and now we're going to go to I2, and B should turn on, which is input or output 1. All right, moving on to I3, B and C, or 1 and 0 will turn on. So you have 0, 1, 1. Next is input 4, and input 4, A should turn on. So you have 1, 0, 0. Now, moving on to input 5. Whatever input 5 is on, you'll have 1, 0, 1. 1, 0, 1. Input 6, you have 1, 1, 0. As you can see here, 1, 1, 0 for input 6. And input 7, they're all on for A, B, and C. All right, that should conclude it for this video for lab number 6. Thank you for your time.